Welcome to another episode of Terry's Notes, and today we're going to be looking at column vectors. And vectors is usually a very difficult topic for most students, but I just want you to pay attention and look at a typical exam question that you would probably see in section 1. Okay, so first thing we need to understand, what is a vector? So a vector basically has a magnitude and a direction, right? Now when we say a magnitude, we mean it has a value, right? And a direction could be north, south, east, west. It has a direction. And we usually use an arrow to represent a vector, right? And the reason why we use an arrow is that the arrowhead gives us the direction of the vector, and the length of the arrow, that's from here to here, gives us the magnitude of the vector, or the length of the vector, right? So the first thing we're going to look at is something called column vectors. So we have an origin here, we have our x-axis, we have our y-axis, and we have some points B, C, D, and E drawn on a graph here, right? Now what I want you to do is to be able to determine what the vector OB is. Now this is how we write a vector. The origin, we label that as O, right? And the vector OB is this line here, this line that I'm tracing over here, right? So this is OB. And what is the vector OB? In order to determine the vector OB, we start from O and we go across 1, 2, 3. So we're going to write 3 as our first number, and then we're going to go up 1, 2, 3. So the vector OB is represented by 3, 3, right? Any let's say OP, any point, we can write a column vector in the form x, y, where x represents the direction and the magnitude or the movement in the x direction, and the y represents the movement in the y direction. So OB is the vector 3, 3. So OC, let's see what's happening with OC. Right, now notice I put a little arrow on top OB, a little arrow on top OC. That is how we write a vector, right? So this is the point C here, and this is the direction OC, right? So in order to move from O to C, we move 1, 2, 3, 4 across. So the first number will be 4, and then we move 1, 2 down. So because we move down, we have to put -2, right? Let's see OD. We move 1, 2, 3 to the left. Because we are moving to the left, we are going -3, and we are moving 1 down. So it will be -3, -1. So this is the vector OD. Right, and let's do OE now. The vector OE, we have to move 1, 2, 3 to the left, right? So it'll be -3 because we are moving to the left, and we are moving 1, 2, 3, 4, 5, 6, 7 up. Because we are moving in the positive right y direction, it will be just 7, right? So keep in mind, when we move in this direction, it's going to be positive. If we move up, it's also going to be positive. But if we move down, it's negative. And if we move to the left, it's also negative, right? So I've given you a point in each of the 4 quadrants of this graph. So these are all the different variations that you can get if you have to identify a column vector, okay? Now let me show you something else now. Now, two vectors can be what we say parallel, right? Meaning that the distance, the perpendicular distance between the two vectors are the same, no matter where we take that measurement, right? Those two vectors, they will never touch. So let's say the vector AB, right? To get this vector AB, it will be 1, 2, 3, 4 across. So it'll be 4, and we go in 1, 2, 3, 4 up. So this is the vector AB, right? And the vector CD will be 1, 2, 3, 4 across. So there's 4, and we go 1, 2, 3, 4 up. So notice the two vectors are the same. So these two vectors are what we say they are parallel. Now, if you have a vector AB, right? But I ask you to write what is the vector BA. Now, BA means that we are starting at B and we are ending up at A, which means we are moving in this direction, right? Because we are moving in the opposite direction, the vector will be minus 4, minus 4, right? Alright, now this is a very important concept here, right? So if I were to tell you that, let's say I give you a vector OP, and I said the vector was 2, minus 1, then what is the vector PO? PO means that I am moving in the opposite direction. What I need to do is to actually multiply the vector by minus 1. So PO will be minus 2, 1. This may seem like a simple concept, but pay attention. It is very, very important. If I give you a vector OX, and I say the vector OX is minus 3, 4, what is the vector XO? We are moving in the opposite direction, right? And because we are moving in the opposite direction, we just need to multiply by minus 1. So this becomes 3, and this is minus 4, right? There's a reason why I'm telling you this. Now, let's go to this next thing here. Right, now this is a typical type exam question. They're going to ask us, they give you a diagram, and they say, write down the column vectors OA and OB, right? So OA is equal to, now we'll start from the origin. We go 1, 2, 3, 4, 5, 6. So it's 6, and we're going up 1. So OA is 6, 1, right? So OA is a column vector. I'm sorry, OA written as a column vector is 6, 1. Let's write OB. OB written as a column vector will be, we go 1, 2, 3 across. So it's 3. We're going to go 1, 2, 3, 4 up. So it's going to be 3, 4, right? The next thing they're going to ask you now is to write down the vector A, B. And this is where students get confused. They look at it and they're like, okay, how do we do this? Do we add the two vectors? Do we subtract the vectors? Now here's the trick. You want to start at A and end up at B. So let's start at A, right? And we're going to use our origin as a point that will get us from A to B. So AB means we're moving in this direction, AO, and then we're moving in this direction, right? Forget about the maths, just look at what is happening here. I want to go from A to B, right? That is the vector I want to find. That is this vector here. And if I start at A, I must end up at B. So if I start at A, I can go along this line to O, and then along this line here to B. So therefore I am going in the direction AO plus OB, right? Seems straightforward enough, right? Now what is the vector AO? Remember in the last slide what I showed you, OA is 6, 1. Therefore AO will be minus 6 minus 1, because AO is in the opposite direction of OA, plus OB, which is 3, 4, right? So minus 6 plus 3 will give me minus 3, and minus 1 plus 4 will give me 3, right? So I got minus 3, 3 as a vector AB. I can easily check this on the diagram as well. I start at A, I move 1, 2, 3 to the left, so therefore it's minus 3. And then I move 1, 2, 3 up, so it's plus 3. Alright, this is a typical examination question. Next thing they can possibly ask is, what is the magnitude of the vector, let's say OB, right? So they might come and they say, what is the magnitude of this vector here, which is OB? In order to write that, we say OB, and we put 2 vertical lines on either side. That is how we represent magnitude, right? And in order to get the magnitude, if you look at this, OB, right, you can form a right angle triangle here. I hope you all are seeing this, right? We have a triangle here. So in order to get the magnitude, you simply use Pythagoras' theorem, because this length is 4 units and this length is 3 units, and we want to find the hypotenuse. So therefore, to find the magnitude of a vector, we're going to take the x value of the vector, right, that is here, which is 3, squared. We're going to add it to the square of the y value, and we're going to find the square root of this, which will be 9 plus 16, which is equal to the square root of 25, which is equal to 5 units, right? So in order to get the magnitude of a vector, we apply Pythagoras' theorem. So once you know, we knew what OB was. OB is this vector here, right? Therefore, we just take the x value and the y value, and we square them, we add them, and we find the square root. All right. Now this is just a simple introduction to vectors. It can get more complicated, and I will do another video to show more advanced topics on vectors. Okay.